Today's topic is topic 5, differential equations. These are always no calculator, and you can see the recent years that they've appeared on the AP exam, the BC exam. They are here more often than not. Okay, usually this is one of the questions that is the same as on the AB exam as well. Alrighty, remember our mantra for solving a differential equations: separate, then integrate. STI, separate, then integrate. We are finding a solution to the differential equation. We're given the differential equation, we're finding y. So of course we have to integrate. But first, we have to separate because there are y's on the other side. Okay? Questions that typically are asked, definitely finding a particular solution. Alright? Use good algebra. Use algebra to move the y's to the left-hand side. Do not use magic to get them over there. There's no crane that picks up your y's and moves them to the other side. Algebra does it. Okay? Integrate both sides. This is where AP is seeing if you know how to integrate. Maybe use U sub. If it's a BC only one, then you'll need to use a biparts or partial fractions, complete the square, one of those things. Okay? Show your work. They're saying, do you know how to integrate? Don't forget the plus C. Find the value of C using the initial condition that's given to you. Be sure to communicate what you're doing every step of the way. Lastly, get y by itself using good algebra. Okay? Alright, another thing that you'll be asked to do maybe is sketching a slope field, usually about 6 points. Sketching a solution curve through a given slope field. Make sure your sketch is a function. Do not draw your curve through a vertical tangent line. Don't do it. Don't pass through a horizontal asymptote. Write the equation of a tangent line, point and slope, right? Point and slope. Find the second derivative. When you're finding the second derivative, don't forget that it's implicit differentiation, so every time you take the derivative of a y term, you need to multiply by dy dt or dy dx or whatever it is. Be able to answer questions using that second derivative. Okay? And then another topic that you can be asked for in these questions is Euler's method. Okay? You're given dy dx. Use Euler's method to approximate a value of y. Okay. Alright. We're going to be doing the problem from 2023. This had a decent average for KHS. It was higher than Texas. It was higher than the global, so that's good. No calculator on these, ever. Alright, a bottle of milk is taken out of a refrigerator and placed in a pan of hot water to be warmed. The increasing, we might need that, the increasing function m models the temperature of the milk at time t, where m is measured in degrees Celsius and t is the number of minutes since the bottle was placed in the pan. M models the differential, M satisfies the differential equation dm dt is this, and at time 0 the temperature of the milk is 5 degrees Celsius. They are giving us an initial condition here. It can be shown that m is always less than 40 degrees. Okay, 40 degrees Celsius for all values of t. Okay, part A. A slope field for the differential equation is shown. Sketch the solution curve through the point 0, 5. So we're going to go down, find 0, 5. It is marked on here for us. We're going to sketch the solution curve. So remember to follow the shape of your little tangent lines here. These are all little tangent lines. There's a horizontal asymptote. We do not pass through it. Remember, you guys, to go all the way through. Do not stop short and put arrows. You go all the way through. This, I can guarantee, was worth 1 point. So part A was worth 1 point. Okay, let's go right next door here and do part B. Part B. Use the line tangent to the graph of M at time 0 to approximate M of 2, the temperature of the milk at time 2 minutes. The line tangent, so we need a point and slope, and then we get the equation of the line tangent. Okay, the point is the point when time is 0. When time is 0, what is the temperature of the milk? They gave us that. It is 5 degrees. So at time 0, the temperature is 5 degrees. What is the slope there? Well, the slope is dm dt at time 0 when m is 5, right? So the slope is 1/4 40 minus 5. That is 35/4. So the equation is y minus the y coordinate is equal to the slope times x minus the x coordinate. But y is going in place of m. X is our t, right? We want to use this to approximate m of 2. So m of 2 is approximately equal to, I'm taking the 5 to the other side, 35/4 times 2 minus 0. Save stop. We're done with part B. Part B was worth 2 points. 1 point was for dm dt at time 0 is equal to 35/4. So 1 point was for the slope, and then 1 point was for the answer, the approximation. Okay, part C. I guess I'll come down here and do part C. I'm getting all wonky here, doing things a little out of order. Well, not out of order, but you know. Okay. Part C. Write an expression for the second derivative in terms of m, and then use it to determine whether our tangent line approximation from part B is an overestimate or an underestimate of the actual value of m of 2. The second derivative is going to give us concavity. If our curve is concave up, a tangent line will give an underestimate. If our curve is concave down, the tangent line will give an overestimate. Okay, so dm dt is equal to 1/4 40 minus m. We want to find the second derivative. They tell us to find the second derivative in terms of m. So we are going to take the derivative of both sides with respect to t. That will give us the second derivative. Okay, if I distributed this 1/4, I'd have 10 minus 1/4 m. The derivative of 10 is 0. The derivative of negative 1/4 m is negative 1/4 dm dt. Do not forget your dm dt. You're taking the derivative of m with respect to t. Okay? We were told to get this in terms of m. It is not in terms of m yet, so I'm going to replace dm dt with what dm dt is equal to now I have written the second derivative in terms of m. Okay. At this point we need to determine, is the curve concave up or concave down? Is the curve concave up or concave down? Up in the original problem, they told us that m was always less than 40. If m is always less than 40, then dm dt here is always positive, true? So this piece right here is always positive. Therefore, the second derivative is always negative. So I'm going to say that m is less than 40, so the second derivative is less than 0. Therefore, a tangent line approximation yields, gives, whatever, is an, okay, it's concave down, so the tangent line is over the curve, over estimate. Okay, that was worth 2 points. 1 point for the second derivative in terms of m, and then 1 point for, they said, overestimate with reason. Part D. Use separation of variables, separate and integrate to find an expression for m, the particular solution to this differential equation with initial condition m of 0 is 5. So we're solving the differential equation. So part D, dm dt is 1/4 40 minus m. Back when we were doing this unit, you guys were really good at this. Okay, I'm going to leave the 1/4. Do not distribute it. It's going to muddy things up if you try to do that. I'm going to divide both sides by 40 minus m. That is the algebra that we're doing. We are dividing both sides by 40 minus m. And then we're going to multiply both sides by the dt. So we're going to get 1/40 minus m dm is 1/4 dt. Okay? We have separated, now we integrate. Okay? The integral of this. It is an ln because the bottom is linear. It is an ln. However, ln of the bottom, but the derivative of the bottom is a -1, so you must multiply by a -1 in the front. We're actually dividing by a -1 in front. That's the antiderivative. They need to see the antiderivative. This is equal to 1/4 t plus c. Now, what to do with this negative? It does not get distributed inside here. So many times I see kids do that. This negative does not fly through that ln and get distributed. You cannot do that. Instead, multiply it on both sides. Multiply -1 on both sides. To get rid of it. Okay? -1 times 1/4 t. -1 times c is just some other constant c. Now e to both sides. Now e to both sides to get 40 minus m, and we're going to lose our absolute values because of how we're about to write e to the side. It is e to that side, right? It's e to that whole side. But using our law of exponents, we can write this as e to the negative 1/4 t times e to the c. And e to the c is another constant. So I'm going to write that as c e to the negative 1/4 t. Now I'm going to plug in my initial condition to find c. So m of 0 is 5. That's what I'm plugging in. I'm plugging in 5 for m and 0 for t. E to the 0 is 1. C is 35. So now I have 40 minus m is 35 e to the negative 1/4 t. So negative m is negative 40 plus 35 e to the negative 1/4 t, and m is positive 40 minus 35 e to the negative 1/4 t. This part was worth 4 points. 1 point, let me write it up here. 1 point was for separation of variables. Always your first point on these. 1 point was for your antiderivatives. These antiderivatives did not involve anything special, so I know that this problem was also on the AB exam. 1 point was for the constant of integration, the C, and uses the initial condition. And the last point was for solves for m. In other words, your answer. So 4 points. Okay, little note. If you don't separate, you cannot get any of the 4 points if you do not separate. Also, if you don't put a plus C, at most you can get 2 of the 4 points. Okay? Alrighty, so that was that problem.